So am I audible to all? I hope I'm
Yes,
audible.
yes,
Uh,
yes.
Thank you. So, so I'm Catherine Sanchna, a PMRF PhD scholar in the Department of Civil Engineering, IIT Madras. So every week on Monday, 6 p.m. to 8 p.m., I will be giving a live session in which for 2 hours. So in which the first hour I will discuss what Sir has discussed in the past 1 week, and in the second hour we will be solving some numericals, some previous year assignment problems, and also the current NPTEL assignment problems if the deadline has ended. So you can, I've recorded this video. I'll be recording this video and I will be sharing it on my YouTube channel. You can access it whenever you want. And also the contents of the slide will be made available to you by the NPTEL team. So let us begin this session. Am I not audible? Hello? Hello?
Y- Yes, audible.
No, someone had texted that I'm not audible, so that's why. Please check your speaker connections. I think I'm audible to others. So I'll just share my screen. So to begin with, let us start with transportation engineering in general. So if you get so in your BTech, you would have been exposed to only geometric design, the basic terms, pavement design, and traffic engineering and management. This urban transportation planning comes into play when you get into the graduate level. So when you get into the graduate level. Uh, 1 second, is there any way where I can automatically admit all? Can someone throw light on this if you are aware of it? Please let me know if you do. So I'll just continue the session. So our focus is on geometric design of pavements. And this transportation engineering course, we are going to discuss only about the highways. Now, this geometric design of highways deals with the physical entities such as the cross-sectional elements, such as the slope, say, um, we can say the cross slope of the road. So this is the road, sorry. So it can deal with the cross-sectional elements of the road or the longitudinal elements such as vertical curve, horizontal curve, the cross-sectional elements such as super elevation, um cross, I mean, the cross slope. So it deals with the physical entities of the highways. And when we go into pavement design, it deals with the structural design of the pavement. So geometric design deals with the physical design of the pavement, and the structural element of the pavement, the structural design of the pavement will be covered in pavement design. And once you have your roadways, how it can efficiently work will be taken care of by traffic engineering division, wherein you work with signals and road signs, road channelizations, or road markings for efficient movement of traffic. Now, let us move on to our area of interest, which is the geometric design of highways. So, to begin with, let us first go into the basics of what Sir was discussing. So, he first started with what is a geometric design. So, as I said, it is the design of physical entities. So, it has to provide a smooth, comfortable, and efficient operation for the users, for the road users. The road users can be anyone. It can be the people who are driving the vehicle, or it can be the pedestrians who are making use of the pavement, or it could also be the stakeholders as in the people who invest on the road. So that comes under for whom. So this geometric design for whom, what I said about road users and vehicles comes, so that it is for those that the geometric design is planned. And what is geometric design is what we saw now. It is the design of physical entities. And why do you need a geometric design? It is so when we want to travel from one place to another, we expect, as I said, a comfortable and a, an efficient movement from one place to another. So, uh, so you need geometric design in order to guide the users of the road. The geometric design should be self-explaining and also forgiving. Self-explaining as in, so when you someone should not be there to guide you how to use the road. The rules of the road should be evident to you, provided you know the basic rules that you undergo when you get the license. So it should be self-explaining and not some hi-fi some hi-fi terms that you need to know before getting onto the road. And it should also be forgiving. For instance, if you happen to be careless and meet with an accident, the road should be able to forgive you. As in, it should not, so you should get away with it with minimal damage. So all this will be taken care of by geometric design. So when you design a pavement, you should keep all these in mind, that it should be safe, it should be economical, it should provide comfort to the users of the road. So that is why we get into geometric design. Now, why? So what? So next, sir will move into what we achieve by doing this geometric design. Just let me let in some people who are there. Queries, I think it can wait till the last. And one more thing is, I think this Google session will end by 1 hour, but this is a 2 hour session. So I request you to join again at the end of 1 hour using the same Google link. So that is what I wanted to say in the beginning also, which I forgot. So now, so Sir will talk about balance between accessibility and mobility. So accessibility, as the term explains, when you plan the roads, the elements of the road or the design of the road, You should plan in such a manner that it should be accessible to you, and also it should provide you with good mobility. Mobility is kind of a new term, but you can assume it as something related to speed. So the mobility, you should be able to achieve a good mobility as well as good accessibility. When your geometric design should be planned out in such a way that it should have a balance between accessibility and mobility. It should provide a comfortable and convenient ride, as I said. It should provide a comfortable and convenient ride. It should be safe, so it should be forgiving design, so it should be safe. So this is what geometric design is all about. Now moving on to the factors that control this design. So any design should have some controlling factors, right? So when you design something, you need to say what are the factors that you are going to consider when you design. Now, this can be divided into three, which is uses and user related, or user and user related. Second one is road system related, and third one is external factors. Now, when we talk about use and user related, so depending upon the use of the pavement, say it can be, I was talking about accessibility and mobility, right? So accessibility and mobility, this can be better understood when you think of your highways and and the urban roads which are close to you. So the highways can be considered as intercity roads, and they have more mobility. So the speed on those roads will be high. Whereas the roads inside your city, where you travel from one place to another, say from your home to school, they are called intra-city roads, for whom the mobility is is reduced because of the traffic, because of the vehicular count, and this and but their accessibility is high. How accessibility is high? I'm able to easily access it. It is just few meters away from my house, so I can easily access it. Whereas the highways, the intercity roads are not so. So depending on the use of the road, say if it is intercity or intracity, this will also control the geometric design of my pavement. Now, coming to strategic as in, see, you would have heard about border roads organization. So there are roads at the border of our country, and our country, border roads being in the extreme locations such as snowbound locations. Um, and our country being in extreme locations such as snowbound locations, you should provide provisions for removal of snow, for safe movement of vehicles in regions of snow. So all these factors should be considered when you design the pavement. So this is user related. What use is of the pavement to you? It is in the border roads, and the border roads, what are the factors that affect the borders, the economic factors, or the environmental factors, and that should be brought in when you design the pavement. And sensitive, say if you are next to a school zone or a hospital zone, that will also play an important role in the geometric design. And moving on to users. So as I said earlier, the users can be us, the pedestrians, or motorized traffic such as vehicles, two-wheelers, cars, trucks, and so on, or non-motorized traffic such as bicycles. Now, why do we need to know the users of the road for geometric design because each one will have different properties. Now, a motorized vehicle will have a different performance when compared to non-motorized vehicle. When you design a road, you will need parameters such as the turning rate or the radius with which a vehicle can turn so that you can design the radius of the curve or say your the turning radius of your vehicle or say of your car and a big tractor trailer combination. Say this is a tractor and it has a trailer attached to it. This will have, so when it tries to traverse a radial curve, the radius covered by it will be different compared to that of a car. So the users of the road, this is for an example. So the users of the road should also be considered when you design the pavement. And also this knowing the users, say non-motorized traffic, since they are slow moving vehicles, they can affect the traffic flow. So maybe you can provide a separate lane for them. So maybe you can provide a separate lane for them. In that way, you need to consider the users of the road for geometric design. Also, future projections. What do I mean by future projections? Now, say my vehicular count is 1,000 for now. 10 years down the lane, it may not be it may not be 1,000. This count would have increased. This is because of the growth in population, the growth rate of vehicles, and so on. So if my users are going to increase, the number of users are going to increase, then my land facilities also have to be my my land for laying the pavement also has to be acquired in such a way such that it can account for the future traffic. So in that way, the geometric design factors such as vehicle number, population will be considered. So moving on to road system based. So based on the type of road, the geometric design has to be the geometric design will be affected. Now, roads can be classified based on their location. As I said, the roads, the highways where you traverse to move from one city to another, we call them as rural roads. And the roads in your city where you move on a day-to-day basis, we call it as urban roads. So based on the location, the roads can be classified. So what this classification can do to your geometric design. So based on this, your width of the road may vary because there are different width for built up area. So your city is a built up area. Your width of the road will depend on the um, on the type of road, on the location of the road, and also the speed will also depend on the type of the road. So geometric design will be affected in such a way. Now moving on to functional based. So functional based and location are more or less related as in, for functional classification, there are six well-known classifications which we have heard about, which is expressway, national highway, state highway, district roads, village roads, uh, arterial, subarterial, collector, and local. So these roads can be considered as urban roads, and these roads can be considered as rural roads. So though they are functional based, they can also be classified as rural and urban roads. And as I said, your geometric design is going to depend on these roads. And I was talking about accessibility and mobility. These roads will have less accessibility and more mobility, and the opposite for the urban roads. Now moving on to traffic volume. So these are the factors that need to be considered when you design the road. So there are terms such as, so these two terms are mainly used for designing rural roads, and these three are mainly used for designing urban roads. Why is that? Because in urban roads, your traffic is not going to be the same throughout the 24 hours. So this is my 20, if this is my 24-hour duration, my traffic is not going to remain the same in the 24 hours. There may be a peak in the morning, say around 8 o'clock or 9 o'clock, where people traverse to offices or schools, and maybe another one peak in the evening time when they return from office to home. So during that time, it is not reasonable to design a road for the entire traffic or one average value of traffic for the entire 24-hour duration. So in that case, I will be picking peak hour traffic. Next, when I design the rural roads will not have peak, the chances are very less that they have peak traffic. In that case, the rural roads will be designed for something called as AADT or ADT, where AADT is the average annual daily traffic and ADT is average daily traffic. Now, let us see what they are in detail. So, average annual daily traffic is obtained by choosing a section of road and taking the traffic count, okay, across this section of the road. So you stand here and you collect the traffic count. You count the number of vehicles for all the hours 24 by 7. So for 24 by 7, so all throughout the day for 365 days. You do this, you get the total amount of traffic, and that you divide it by 365. This you will call it as annual average daily traffic. Now there's something else called average daily traffic. This is very similar to annual average daily traffic, but um, you won't be considering 365 days because of some issues maybe, and in such cases you will make the traffic count only for 3 to 7 days, with the ideal case being 7. And if you have no other go, you take the traffic count for 3 days continuously, 24 by 7. You take the traffic count with the class of vehicles. You should also classify them according to the type of vehicle, and also you should count the number of vehicles in each class, and that you divide it by 3, sorry, not 365, by 7 or 3. So that you will call it as um, average daily traffic. Okay. Now moving on to the composition. Sorry, not moving on to the composition. We did not see peak hour traffic. So moving on to peak hour traffic. So peak hour traffic, as I said, it is not reasonable for you to use the entire 365 365 days traffic for urban roads, and in such cases you need to use and in such cases you need to use peak hour traffic. So this is daily hourly volume, sorry, daily hourly volume, and this is directional daily hourly volume. There's a difference between those two. So what daily hourly volume is per day per hour. So you divide the volume count per hour. For each hour, you find out the volume of traffic. That is the daily hourly volume. Now, what is directional daily hourly volume? directional daily hourly volume takes into account the direction of traffic. So we all know that our highways will have traffic moving in one direction and traffic moving in the opposite direction. Now, if you consider the direction of um, the movement of traffic into account, you will call it as directional daily hourly volume, and this you will call it as, if it is not considered, then you will call it as daily hourly volume. Now, this daily sorry, this is not daily hourly volume. I'm really sorry. This is design hourly volume. So because you will design only for one uh, for an hourly traffic. Okay, so this is design hourly volume and not daily hourly volume. So here we use daily. Here it is design. Now this design hourly volume, which hour should I take? That you have to find out. Now that is how this design hourly volume is taken based on 30th hour hourly volume. So what do I mean by 30th hour hourly volume? So let us move on to a new slide. So what you have to do is, what they do is, for 365 days, so for 365 days, all throughout the year, so sorry, for 365 days, they find out the hourly volume for each hourly volume. For each hour, they find out the volume count, and that they will arrange it in descending order. Say, so 365 into 24 will be the number of hourly volumes that I will have. Now, what hourly volume should be considered for the design of the road? That we take as 30th hour. How do I take this 30th hour? First, I will find out all the hourly volumes for 365 days, 24 hours a day, and I will arrange it in descending order. So I will arrange it like this, and it will follow some trend. Now I will leave first 29 hours, this traffic corresponding to the first 29 hours. When I arrange it in descending order, I will ignore this. I will not use this for my design. I will pick the 30th hour volume, the traffic corresponding to the 30th hour, that I will use it for design. This is because if I pick this hour, I'm designing the pavement for this 1 hour of traffic for for the entire lifetime. I'm going to design this pavement for this traffic which will act on this pavement only for 1 hour, which is not economical, right? So I'm going to say that for 29 time, for 29 hours in a year, I'm going to say that this road, the traffic on this road can exceed the traffic for which I have constructed the pavement. For the remaining hours, my road will be able to take care of the traffic that is coming onto the pavement. So that is the 30th hourly volume concept. Okay. Now moving on to PCU. Um, so the composition here will also play a role. As I said, each vehicle will have a different performance. A tractor trailer combination will have a different turning radius, okay, when compared to a single truck. Okay, so this the performance will depend on the type composition of traffic. So the composition will also play an important role in the geometric design of highways. Now moving on to now moving on to PCU, which is passenger car unit. So why do we have this concept of PCU? And how do we find out PCU? So this PCU is called passenger car unit. So whatever design you do, you should consider a design vehicle. If you remember or if you know the pavement design concept, there the design vehicle is 80 kilonewton load, 80 kilonewton, single axle dual wheel is the design axle. Okay, whereas in the case of design of highways, where you design the physical entities, the design vehicle is different. So based on the design that you are going to do, the design vehicle will vary. Okay, now why do we need this concept of design vehicle? The traffic on our road is heterogeneous, right? Heterogeneous as in it is a mixed traffic. I will have cycles, bikes, two-wheelers, four-wheelers, trucks, and each will have a different performance. The speed of them is different, which will affect the design of the highways. The area covered by each of these vehicles is different. The performance of these vehicles is different. So all have to be taken into account when you design the pavement. But if you take each of them separately, it is going to create a confusion, or it is going, or maybe not even feasible. So, in order to make it simpler, you convert the different class of vehicles, this heterogeneous traffic, into one standard vehicle. Okay, and that is what is the passenger car. So you convert all these vehicles into passenger cars. So um, if I say my cycle has a PCU value of zero point 0.5, one passage of cycle is equivalent to zero point 0.5 passes of passenger car. Okay, so that is the concept. So how do we design? So if you go back here, if you know pavement design, if I have to take an example, here you will say that, say there's um, 80 kilonewton load, all the axles will be converted to 80 kilonewton loads, and say if you have some um 90 kilonewton passing on the road, you will say that this will be converted to equivalent repetitions of 80 kilonewton. So maybe zero point 0.9 times of 90 kilonewton is equivalent to one time of one time means one passage of 80 kilonewton. But how do we bring this equivalence? This equivalence, we say, it has to be in terms of strain. Maybe I'm comparing the strain, or maybe I can even uh, compare the distresses. Say this zero point 0.9 times of 90 kilonewton will produce the same amount of cracking that one passage of 80 kilonewton causes. This is how the equivalence is established for pavement design axle. Whereas for this passenger car unit, there is one sorry, there is also the equivalence is achieved based on the vehicle speed and the projected area. So how much area each vehicle covers with respect to the passenger car, and what is the speed of each of these vehicles with respect to the passenger car. So by using these two parameters, vehicle speed and area, you can find out something called as passenger car unit and convert all the vehicles into passenger cars. Okay, I hope this concept is clear. Uh, Queries, can we please have it at the last? Okay. Now moving on to and now we are done with passenger car unit. I will obviously explain your doubts, but please wait till the end of this session because we still have problems to solve. Or maybe after me explaining this, we will have a doubt clarification session and then we will move on to problems. Okay. Now, you can also open your, like, unmute yourself and speak if because I cannot be checking the messages then and there. Now, moving on to the next one, which can affect the design of highways, is the design period. So, a design period, as you all know, every structure will have a design period, right? Design life. So, my road will also be designed. So, I will not construct the road only for this year. I will construct the road for future also so that the future traffic can also be accommodated. So if I take the design year as 20, then I have to accommodate 20 years of traffic in designing the pavement today's pavement. Now, if my traffic is, say, as I said, 1,000 counts per for this year, the next year also it won't be 1,000. It may be 1,050. The next the year after that it may be 1,100, and this may increase. And this is taken into account by growth rate. So you will not be designing the road for today's traffic. You will be designing the road for traffic for the 20 years or for the design period that you have considered. And also, this traffic will not remain the traffic count will not remain the same every year, whereas it will keep on increasing with year, which is accommodated in growth rate. Okay. Now moving on to design speed. So design speed is a very important concept in the design of highways. Um, 1 second. Yeah. So based on your classification of roads, the speed of the vehicle, the design speed on that road is different. Okay. As I said, if the roads are rural roads, the mobility is high. Mobility is in, speed is high. And for urban roads, the speed is low. For expressways, the speed is very high. Okay. So, and there are IRC codes which will tell you for what speed the road should be designed. Okay. Um, so you will design the road for something called as 98th percentile of speed. Okay. Now, what is this 98th percentile? Yeah. So what is this 98th percentile? Say my traffic is heterogeneous, as I said earlier, right? Now, this heterogeneous traffic, mixed traffic, can have speed ranging from very low speed to very high speed. Okay, say my speed of bicycle is 10 kilometers per hour, for example. Okay, and my speed of and the speed of the this is the slowest vehicle, and the fastest vehicle that is traversing the road may be at 100 kilometers per hour. Okay. Um, so I will find out the number of vehicles traveling at each speed range. So I will classify the speed as, say, 5 to 15, 15 to 25, 25 to 35, and so on. And I will find out how many number of vehicles are there for each speed range. Okay, say 10, 15, and so on. Now what I will do, I will plot them such that, um, so this here it will be speed, the mean value of the speed, say 10, 20, 30, and so on. So in the x-axis it is the mean value of speed, and in the y-axis it will be percentage greater than. So you will find out how many number of vehicles are traveling with a speed greater than 100, greater than 10. Okay, and similarly, you will say how many number of vehicles are traveling with a speed greater than 20. In that manner, you will plot, so that will be your y-axis. So percentage of vehicles greater than. Okay, in that manner, you will get, one second. So I'm not sure if it is greater than or less than. You will get an S-shaped curve like this. Okay, so it should be percentage of vehicles greater than or less than. I will just check and let you know. And this is the speed of the vehicles. Now you will pick the 98th percentile here and the speed corresponding to this 98th percentile. This is the speed for which you will design the highways, the road. Okay. So this is the design speed, and this speed also has a very important role in the geometric design of highways of your pavement. Now moving on to, and there are IRC codes which tell you what should be the minimum, what speed should be provided for each class of road, and they have also something known as ruling speed and minimum speed. So they say that you should ideally provide the ruling speed on the pavement, on the road. Okay, it means that your vehicle should be able to travel at this ruling speed. Okay, but under extreme conditions where, because of the topography of the pavement or some extreme cases, if there are any issues, you can go to minimum speed range, but in no case should you decrease below this minimum speed. If you decrease, then the performance of the road will decrease. Okay, so this is what IRC says. Now moving on to capacity. So capacity is also a very important factor. Now what is this capacity? Capacity is the maximum hourly rate at which the vehicles traverse in a given road. Okay, so if this is my road, if I stand at this cross section, and if I count the number of vehicles passing per hour, that is the volume. Okay, so I stand here and I count the number of vehicles passing for a given hour. Say from 8 o'clock to 9 o'clock, I'll count the number of vehicles passing this section. That is the volume. Now, what is capacity? Capacity is the maximum volume that can traverse this section. This is known as capacity. Now, how is this calculated? So this is given by is equals to 1000 into V by S. This 1000 is nothing. It is just to convert kilometers to meters. So it is simply V by S. What is V? V is speed. Speed is in kilometers per hour, or it can be in meters per second. And what is S? S is the spacing between the vehicles, which is maybe meters. Okay. Now, if you see the units of this, it will be per second, right? Per second. So capacity will be in number of vehicles. Number does not have any unit, right? So vehicles per second, or mostly it is not given in seconds because it is vehicular count. You cannot give in seconds. You will give it in hours. So this you will convert it to hours and you will say vehicles per hour. Okay, so that is capacity. Now, this is also given per lane. Not so if there are three lanes in one on one side of the road, and if you are making the count, you have to divide it by the number of lanes as well. So capacity is vehicles crossing a particular section of the road for a given hour for a given lane. Okay, so that is maximum. Okay, maximum vehicles crossing. So that is capacity. Now, how is this calculated? As I said, it is speed by spacing. Now, I take this section. This is my vehicle and it is crossing the section. Okay, it has crossed. Say it is crossing it at 80 kilometers per hour. Now, the second vehicle cannot cross the section immediately, right? It can the second vehicle will not be at the end of the first vehicle, whereas it will have some spacing, right? So if the first vehicle is here, the second vehicle will have some spacing and the second vehicle will be here. So this spacing will also affect my capacity because capacity is the number of vehicles crossing the section. And if the spacing between the vehicles is more, then the number of vehicles crossing a section for a given hour will also change. Okay. So the speed will also influence the capacity, and the spacing will also influence the capacity. Um, so that is how capacity is calculated. Okay. So moving on to the next road system related concept, like the next factor, it is level of service. Now, what is level of service? Level of service is just a um, kind of a factor to define how efficiently you have designed the road. Okay, so I'm constructing a road and it is going to be of service to you. It is going to serve you in some way. It is going to serve you in transporting yourself from one place to another. So how good is my service? Is my service very good, or is my service poor, or is my service fair enough? So that is given by level of service. Now, if my pavement or if my highway is extremely comfortable, I will say that it has a level of service of A, and it has like that. It has 6 levels of service from A to F. F being very poor. Okay, so it is very difficult to provide a level of service of A because you might have to invest a lot to give a level of service to give a very comfortable pavement. Sorry, a very comfortable highway. So mostly we give level of service as B or C. So we design the pavement, we design the section roadways such that the level of service offered to us by that roadway is either B or C. A will make it more uh, like costly, and below C, D is also acceptable, but E and F will reduce the performance of the pavement, will reduce the performance of the highway. Okay, so mostly we design the pavement for B and C level of service. Um, and they say that up to level C, we will be able to get stable flow. Now, let me just try to explain this curve. So this curve is something like this. Okay, we saw something called as capacity, right? Capacity, so this is the speed of the vehicle, and this is the flow or volume. Okay, flow or volume. Now this maximum value is what I will call it as capacity. If you remember correctly, I said that I will stand and count the number of vehicles passing a cross section, and that is the volume. And the maximum volume that I get is what I will call it as capacity. So, in this graph of volume versus speed, speed versus volume, the maximum value is capacity. And if you see here, let us understand this graph. So, if we see here, if the volume is very less, if the volume is zero, it can mean two situations. It can either mean that my roadway does not have any vehicle on the road. It can either mean that my roadway does not have any vehicle on the road, which means the speed is zero, or it can also mean that my vehicles are not at all moving. That is, my road is jam packed. That when I stand at this cross section, so say if there's a traffic jam and you're trying to count the number of vehicles passing this cross section, this section, okay, this section of the road. How will you be able to count if there's no movement? If there's a traffic jam, then there's not going to be the vehicles are going to remain stagnant, which means there's not going to be any movement across this section. In that case also, the flow is zero and the speed is zero. So these are the extreme cases. Now, as the flow, so if you go from here, from the top, as the flow increases, the speed is going to decrease. So as the flow increases, so I take a roadway, I put one vehicle, it is going to travel at one speed. Okay. Now I'm going to put two more vehicles. Then the speed of this traffic stream is going to be less because I'm keeping on adding the vehicles. So it is decreasing. Okay. Now, till this level of service C, I will call it as stable flow, which I will what aim for. Okay. Beyond this, I'm not going to aim for this because the speed is going to drastically decrease. Okay. And the capacity of the road is also the volume is also no, sorry. Um I'm not going to go beyond this because my speed is going to decrease. Okay, so this is what this graph tries to explain. And there are external factors which affect the geometric design. So one is the topography. So based on the topography, based on the cross slope is nothing but, say this is my mountain. Okay, this is my mountain, and my vehicle is traveling in this direction. Okay, this is the cross slope. Okay, this is the cross slope. Most of us will think that the longitudinal slope is the cross slope. The longitudinal slope is not the slope with which these terrains are defined. It is the transverse slope, that is the transverse slope when the vehicle is moving in this direction is the cross slope. So based on this slope, the topography is divided into four divisions, and based on this topography, the speed will vary as per IRC. So this will also affect the geometric design of highways. Now, most of us would have seen that when you go to hill stations, you're not going to have only one slope, but it is going to have hairpin bends. It is going to have hairpin bends when your vehicle moves from the top to bottom or bottom to top in a mountainous terrain. It is going to have hairpin bends or curvatures. So based on that, also the topography is defined as low curvature and high curvature. Okay, so that also plays a role in highway design. And there are some more external factors like the funds available. So when you plan for construction, you should have the amount of money to construct. If you are not having the amount of money, you can go for three options. One is stage construction, wherein you say that for the current traffic, it is enough if I provide two lanes, for example. And maybe when I maybe 5 years down the lane, I have to increase this number of lanes to three lanes. So this is called stage construction. I'm constructing only a part of the service that part of the highway that I want, like only two lanes, and because I have only that much amount of money. Few years down the lane, when I have some more amount to construct the remaining, I will add on to one more lane. Okay, or you can give your construction to a private sector, and you can ask them to construct the road for you. You can also ask them to construct the road, operate the road, and maintain the road. So this is how we have toll plazas. So the toll money that they collect, that they will use it for maintenance. That is what they call it as operation. So when you so I'm a government agency, and I will give the contract to a private company for constructing a section of the road. So what gain does the private sector get? Okay, it is just going to construct the road. How is it going to earn from it? So that is how you will have toll plazas. So they say that if you want to use this section of the road, you have to pay me. Based on that, only they earn the amount that they get, that they have put for laying the road. Okay, so that is called public private partnership. So they can do that, or they can also borrow money. So based on that also, your geometric design will vary. Okay, so based on the funds available, your geometric design will vary. And safety. So as I said, your road design should be forgiving. It should be safe to the road users, the vehicles, the pedestrians, and also the properties that are adjoining the road. Okay, so the properties nearing the that are near to the highways should also, you should consider the safety of that as well when you construct the highways. And there are many other external factors. Now we'll move on to, since we've exceeded the time, we will move on to problems. Okay, so these are previous years assignment problems. Now the first question is the geometric design of, so many people were asking doubts, right? Sorry. Yeah. Uh, can you please ask your doubts now? Whatever you want me to explain again, I can explain that also now. Yes, I will explain this 30th hour concept. So while I explain this concept, please type in your other queries as well. Okay. So what is this 30-hour concept? One second. So I have a road. I have to design a road. Okay, road. Now, I need to know the number of vehicles that are, so this is my roadway, and I need to know the number of vehicles that are traversing on this roadway, because the roadway width, the number of lanes will depend on the number of vehicles that are traveling on this roadway, right? Now, there is a, now, how will you determine the number of vehicles that for which you need to construct this road? Here, there are concepts called, as I said, AADT. ADT, and design hourly volume. Okay, something like that. Now you want to know this design hourly volume. Why do we use this design hourly volume? As I said, my roadway is not going to have vehicles all 24 by 7. Okay, it may have, so if I take an hourly distribution of traffic, so this is hour and this is volume. If I take an hourly distribution of traffic, it is going to have, say, 100 vehicles for till 8 o'clock in the morning. Then from 8 to 9, it is going to have 500 vehicles crossing a section, okay, that is traveling on the roadway. And maybe the remaining, it is going to have, say, 200 vehicles. And then again in the evening, around 5 to 6, 5 o'clock or so, it is going to have, say, 550 vehicles, and again it is going to go back to 100 vehicles, say something like this. Okay, now I have to design the pavement. Now design the highway. Which hourly traffic will I choose? Which traffic should I choose? Should I take 100? Should I take 500? This is for one particular day. Okay, so this is for 24 hours. This is for one particular day. Which one should I choose? This is only for one particular day. Maybe the next day this 500 can go up to 1000 also. Okay, now for the next day, I might have 200 till 8 o'clock, then 1000 from 8 to 9, something like that. So there's going to be different volumes of traffic that the roadway is going to be subjected to, right? So if I write all this down, say from 8 to 9 o'clock, it is 500. This is for one particular day. Say what is 31 7 July. 8 to 9 o'clock, it is 500. 9 to 10, it is 200. 10 to 11, it is 200. Like that, I will write it for one day, all 24 hours. Okay, how much is the traffic that is going to come on the pavement for each hour? In the same way, this is for 31st July. Now for 8th August also, I will do the same. So for 24 hours, I will know what is the traffic that is coming onto the pavement for each hour. Now like that, I will have this 24 hours of traffic for 365 days. For all the 365 days, I'm going to have traffic volume count. Okay, now which one should I choose for design? Now I have so many hours of traffic. I said I should design for hourly volume. I should design for one hourly volume, and now I have 365 into 24 hourly volumes. Now which one should I pick for design? So for that, now you will be having this much of data. Say it is n data. So you have n hours of traffic. I will arrange them in descending order. Okay, so as per the previous example, 1000 is the highest. So 1000 is here. Next, I have 500. Next, 200. Next, 100. Like that, I will arrange all the traffic volume in descending order. Okay, so this is, and I will name it as, say, 1, 2, 3. So this is 1000 is 1, 2, 3. So I will name it and name it such that, so this will be the number of hours. Just take it as number of hours. And this is the descending order of the hourly volume that I just took. Now, which one I will choose for design? I will not choose the highest for design. I will obviously not choose the highest for design, because for all the 365 days, there's only 1 hour for which this highest volume is going to come onto my pavement. I am not going to construct my pavement for a design period of 20 hours based on this hourly volume. Why? Because it is not going to be economical. For this 1 hour of traffic, I'm not going to construct 6 lanes. So I'm going to come to a negotiation. I will say that I will leave the first 29 hours and I will pick the traffic correct. So 29 I will neglect. 30th hour you take, and you take the traffic volume corresponding to the 30th hour. Okay, so this is what I will take for designing the road. Okay, what will this mean for the entire 365 days? There are 365 into 24. So there are this many hours in 1 year. Okay, total number of hours in 1 year. I'm going to say that 29 times of the year, say this is say 50. Okay. So for 29 times of the year, my traffic is going to be greater than 50, and my highway might have a problem. It might have congestion, it might have traffic, whatever. But I'm not going to care. I'm going to leave that 29 hours. You can exceed the traffic for which I am designing. But for the remaining hours, the traffic is obviously going to be less because I've arranged this in descending order, right? So I'm going to pick this 30th hour, and I'm going to say that I'm going to design my highway for this volume count. Is this fine? Uday, is this fine? Thank you. Rahul is here, or does anyone want any other concept to be clarified? So please text it and keep. We'll go see the problems. Okay. So the first problem, first question, geometric design of highways is related to what? Okay. Is it related to travel demand estimation? No, because that is, I have to design the physical entities of the pavement. I'm not going to estimate. I don't have any work with the travel demand estimation. That comes under urban transportation planning. Okay, that is what I showed in the first slide. I showed four major divisions, right? So that will come under UTP. Design of cross-section of alignment. Yes, we saw that. It is going to, we are going to design the physical entities of the pavement. So yes, it is the cross-section. Am I going to design the pavement crust? No, because this will come under pavement design, right? Um, what because here I'm going to pavement crust means I will say what materials I am going to use for constructing the pavement, and this has nothing to do with geometric design because geometric design is only the structural orientation, like the physical entities, the alignment, the cross section, like that. Okay, planning of highway development. This is also not my concern. Okay, so the answer is B. Now, moving on to the next question. Geometric design is carried out to ensure adequacy of facility in horizon year, economic design, forgiving design, self-explaining design. This we know. I explained forgiving design. Yes, it is. It should be, my geometric design should ensure forgiving design. It should be a self-explaining design, and also we also saw that it should be economical, and horizon year is nothing but design period. Okay, so I said design period is also one of the factors in determining the geometric design of highways. So that also um, is the correct answer for this question. Okay, now moving on to the next question. So we will try to match the following. So cross-sectional elements. I'm not sure. Okay. So cross-sectional. So this you need not know everything. This and all were found from assignment 0 of your current NPTEL course. So you need not know everything, but by matching the remaining, you can find out where goes what. Okay. Alignment design, I said alignment, it will, horizontal alignment is there, which is the radius. Vertical alignment is there, which is the slope of the curves, which is vertical curves. So alignment design can be matched with D. Okay, so 2. Okay, and intersection layouts and geometry. So when you learn about intersections, you will learn something called as auxiliary lanes. So this can be mapped to auxiliary lanes. And design of facilities, um, parking area is a facility which needs to be designed. Okay, so that also will come, so that will come under design of facilities. Now the remaining one is cross-sectional element, which will be the pedestrian design. So if you match all this, the answer that you will get is C. Okay. Now, now moving on to the next question. If you have any doubts, just type it in the comment section or just stop me in between. Now that we are solving problems, you can stop me in between and ask. I will explain it. Okay. Now, so let us read this question. A vehicle moving at a speed of 54 km per hour on a road starts decelerating at a rate of 25 meter per second square. The time taken by the vehicle to come to a halt before colliding with an object on the carriageway would be what? Okay, so this is also there in assignment 0. So don't get scared that nothing is taught but this has been asked. This is nothing but based on the school physics that we learned. So we know that, so we know general like common terms like deceleration, acceleration, velocity, and all that. Okay. So based on that, you can solve this problem. Now, what is deceleration? What is acceleration? It is the rate of change of velocity, right? Change of velocity. So let me take the final velocity as v and the initial velocity as u. So rate of change is change in this velocity with time. So any term which has any term which has the word rate, it means that it is with respect to time. So change of velocity with time. So final velocity minus initial velocity divided by time is acceleration. So acceleration is the velocity increases with time. You accelerate the vehicle. So you start from zero and you accelerate the vehicle, or you start from a low velocity and you accelerate the vehicle, you increase the speed of the vehicle. So that is acceleration. That is the final velocity minus initial velocity divided by t. Now here it is given deceleration, right? Deceleration is I'm bringing the vehicle to a stop or I'm reducing the speed of the vehicle. So it is also v minus u by t, but you know very well that this uh, this one, the initial velocity will be higher than the final velocity. Initial velocity will be higher than the final velocity because I'm decreasing the speed of the vehicle. Okay, so this is deceleration. Okay, and this deceleration should have a negative value. If you are using the same equation, then how will you differentiate between acceleration and deceleration? So acceleration will be positive and deceleration will be negative. Okay, if you are using the same equation. If not, you should just flip the terms of this equation to u minus v by t is equals to deceleration. Okay, only then it will be a positive value, right? Here u is maximum, so d should be positive. Here v is maximum, so a will be positive. Okay, basic physics. Now you just substitute the values that they have given here in this equation. So deceleration rate of 2.5 meter per second square. As I said, deceleration is negative, so minus 2.5 is equal to, so it was moving with a speed of 54 kilometers per hour and it is brought to a stop. Okay, the time taken to a vehicle to come to a halt. So my final velocity is 0 and my initial velocity is 54 kilometers per hour. Okay, so substituting this here, 0 minus 54, this is in kilometers per hour, this is in meter per second square. So, and you want the time in seconds. So, so you should balance the units, right? So you should balance the units, right? So convert kilometers per hour to meters per second. And how will you do this? 54 into 1000. So this will convert kilometers to meter. Into 1000 will convert kilometers to meter. By 3600, this will convert hours to seconds. Okay, so 1 hour is equals to 3600 seconds, right? And 1 kilometer is equal to 1000 meters. So this will convert kilometer per hour to meters per second. So this is 1000 divided by 3600 whole divided by time. So you need what time is. Okay. So moving on to so what we wrote here, minus 2.5 is equals to 0 minus 54 into 1000 by 3600 by t. So this will give me t is equals to 15 by 2.5 and this is going to be 6. So my answer is going to be 6 seconds. Okay, understood? 6 seconds. Now the next question. Geometric design of highways deals with the dimensions and layouts of visible features provided as a part of cross-section of the highway. Is this correct? By reading the statement itself, you can figure out that it is correct. Okay, it deals with the dimensions, visible features, cross-section of the highway. So this statement 1 is correct. Traffic characteristics, driver behavior, and vehicular characteristics influence the geometric design of highway elements. Obviously, because we saw the controlling factors that control the design, and it had traffic, it had user behavior, which is driver behavior, which is user, vehicular characteristics, which is also user. So this is also correct. So the correct answer for this is both statement 1 and statement 2 are correct. Okay. Now moving on to the next question. Okay. So the factors which control the geometric design are, you know very well, we saw road user characteristics, we saw vehicle characteristics, we saw, did we see material used in pavement design? No, this is in no way going to affect the geometric design of highways. We saw topography. So these three are the answers to this question. Okay. Now, moving on to this, minimum lane width for single lane roadway for highway as per IRC guidelines. Okay, so this I've taken a screenshot of the IRC guidelines. So this is the minimum lane width. So for single lane, the minimum width of carriageway is the road. Okay, so the road is sometimes called as the carriageway, and the minimum width for single lane. What is single lane? I have, you know what lane is, right? So this is one lane of traffic. This is second lane of traffic. These will be either divided by a barrier or maybe dotted lines if they are on the same line, something like that. So for single lane, the minimum width is 3.75 meters. So if you see, um, this figure, you can see that the standard width of the vehicle is close to 2.5 meters. Okay, and you need to provide some space to the left and right of the vehicle on the road. Okay, and when you provide that all together, it will become 3.75 meters. This is for single lane. Okay, now for double lane, the minimum width of the lane is the minimum width of the carriageway. Carriageway is the total road. Okay, it is 7 meters. I'm giving you extra information. This is the answer to our question. So answer is 3.75 meters. For two lanes, if you have two lanes, okay, one lane, second lane. If you have two lanes, then and there's no curb, then the minimum width is 7 meters. And if it has raised curbs, what are curbs? So you are on a road and you would have seen some raised provisions here. So raised stone like things here. Okay. Maybe this is the median, the separation. Okay. Or and this is maybe the edge of the road. So these are curbs. If they have raised curbs, then the minimum width of the carriageway is 77.5 meters. And there are something called as intermediate carriageway where the width of the carriageway is 5.5 meters. Okay, and multi-lane. So multi-lane is more than two lanes. Okay, we saw two lanes, minimum width for two lanes. If it is more than two lanes, say three lanes or four lanes, then each lane should have 3.5 meters. Okay, so this is the answer to the question. Now moving on to the next question. So here it is 3.75 meters. So the main features considered in geometric design of highways are. So what are you going to design? Going to consider. So what features are you going to design in the geometric design of highways? So it is, as we saw, cross-sectional elements of highway. I'm talking about cross-sectional elements, but I don't know if you know what cross-sectional elements are. So I'll just give a small example. So you're traveling on a road. Your road is not like this, flat. So this is your vehicle. Okay. You're traveling in this manner, longitude, into the laptop. That is the direction of travel. Your roadway is not going to be straight. It is going to have something called as camber. Okay, it is going to be like this. This is the cross-sectional element of highway because when I cut the cross section, cut across the highways, this is a physical feature that I'm going to provide for some reason. It can be drainage or it can be for balancing the vehicle. Okay, so something like that. So this is the camber, and this is one cross-sectional element. There's one more cross-sectional element when you travel on the curves. Say uh, if your vehicle is traveling in this way, your vehicle will be subjected to some centripetal acceleration, right? Because of which your vehicle will be, uh, in order to balance the vehicle, okay, in this curved section, your cross section, your road cross section will not be something like this, but it will be raised on one side, okay, in order to balance the vehicle. So this is called as super elevation. So this is the cross-sectional elements that I'm talking about. Camber, super elevation. Okay, that and all will be it will come in the upcoming sessions. So and side distance, it comes in week 2. We will see what side distance is. Horizontal alignment, as I said, horizontal alignment is nothing but the radius of the curve, and vertical alignment is maybe it is a valley curve or a Um, so it is this curve, or maybe it is a going up curve. Okay. So these are the features which will be designed in, which will be designed in this course. Okay. So the answer for this is all the four. So moving on to the next set of questions. Now also we will do match the following. So exclusive use facility, it is there in sir's slides that you can have exclusive facilities for cyclists separately, maybe for pedestrians separately. So it is going to be so this exclusive use facility is based on the user based, what the user wants. Okay. Second one is gradient. Gradient is nothing but topography. We saw no cross slope and all that. So this topography will come under external factors. We saw this also that it comes under external factors. Traffic growth rate is related to traffic, and we saw that traffic comes under road system factors. So these are the factors that we are talking about, and this is the major division under which each factor falls under. Okay, major division. And mobility is use based. Um, Mobility we saw, right? Intracity, intercity, and all that. So it is use based. So the answer to this is D. Moving on to the next question. Traffic will be attracted to, um, it will be attracted to activities. Will it be attracted to activities? Of course, it will be attracted to activities. Say you're having shopping in one area, one zone, then the users who want to go to the shopping complex will be attracted to the activities in the complex, right? So your the traffic will be attracted to the activities and also to the land use. You are in a residential area, your school is in educational area, and so your traffic will be attracted to from home to school or school to home. So land use also is the answer to this question. And transport system development, vehicle population, no, these are not going to attract the traffic. Okay. Now moving on to the next question, the road category which provides least accessibility. If you remember when I explained for the first 1 hour, I said that expressways, national highways, state highways, village roads and other roads, they all come under rural roads. And these rural roads will have least accessibility. Okay. And they will have more mobility. So among all these roads, national highways will have the least accessibility. Okay. Now moving on to the next question. The sub-arterial roads fall under. So sub-arterials, as we saw, we below this we wrote arterials, sub-arterials, collector roads, local roads, and so on. So this sub-arterials will fall under urban roads. Okay. So the top one is rural, this one is urban. So this is urban roads. Now moving on to the next question. So annual traffic recorded on a 1 kilometer long road section is 4 lakhs. Out of this, 40% travel in one direction and rest in other. If 200 vehicles pass through the location during peak hour, then DDHVs, that is directional design hourly volume in vehicles per hour would be what? I did not explain what the formula for DDHV, right? So when I explain this 30-hour design hourly volume, this hourly volume here is usually expressed as percentage of AADT. What is AADT? AADT is annual average daily traffic. Say if this is 4 lakhs as mentioned here. Okay. Sorry, this is not daily traffic. This is annual traffic. Okay. So for example, let us say um, this usually DDHV is obtained from AADT because um, say 1 lakh vehicles are you get one you get um sorry you get 15,000 or 1,500 vehicles as AADT. Say you have 1,500 vehicles. You usually express DHV as design hourly volume as some percentage of AADT. Say if DHV is 150, I will say that my DHV is 10 percentage of AADT. So this is how DHV is usually represented. Now what is design daily hourly volume? It has a directional design hourly volume. It has a directional term D in front of it. So it has to consider the effect of direction as well. So if you read this question carefully, this 4 lakhs has nothing to do with your question because they have already given that 200 vehicles pass through the location during the peak hour, which means your design hourly volume is already given as 200. So you need not take this and divide and multiply it by some percentage. This is not necessary because they've directly given you this DHV. So DDHV can be D into DHV, where D is the um, directional factor, okay, or DDHV can be some percent, say K into AADT into D, where K will tell you how much percentage of AADT is DHV, okay, understood? Now you have DHV as 200, they've given it directly, and they've said that 40% travel in one direction. If 40% travels in one direction, it means 60% travels in the opposite direction. And for designing, I should always take the highest value. So I should take 60%. So DDHV is always the highest value, highest of the two. So 200 into 60 by 100 is going to be my DDHV, which is 120. So the answer to this is 120. Everyone understood this? Does anyone have any question? Yeah, so moving on to the next question. Traffic volume in PCU per hour for the following data. So this is the data that they have given. Vehicle, plan area, free flow speed, and vehicles per hour. Okay. So as I said, the heterogeneous traffic is converted to homogeneous traffic by applying PCU. Okay, so if I say I have 10 cars, 5 bicycles, 100 trucks, all this will be multiplied by corresponding PCU value. Each one will have a PCU value. So the PCU value of car is 1 because PCU is passenger car unit and the PCU value of car is 1. Okay, and bicycle maybe it is zero point 0.5 and trucks maybe it is 3. So they have a PCU value. Now this has to be multiplied with the original volume to get homogeneous traffic. Okay, so 1 into 10, 5 into 0.5, 100 into 3. So this means 300 passages of passenger car is equivalent to 100 passengers of trucks. Okay, so the passenger car unit has to be multiplied with the heterogeneous traffic count to get the homogeneous traffic count. So this is the basic idea. Now, how to get this PCU? We saw an equation, or maybe I did not give you the equation, I guess. The equation for PCU is, I told you that it will depend on velocity and projected area of the vehicle. So, a velocity of passenger car, divided by velocity of the vehicle, of any vehicle, divided by projected area of the passenger car divided by projected area of any vehicle. So this is how you will calculate PCU. Okay. Now I will show you how this is calculated. So this is the value of area A, and this is V, and this is volume. Okay. Now I have to find out VC by VI. What is VC? VC is velocity of car. Velocity of car is 60. Okay. And that has to be divided by velocity of the vehicle, which is here. Again, it is car. So it is 60 by 60. It is 1. That is why I get 1. Now, velocity of, if I come to bus, it is velocity of car divided by velocity of bus, which is 60 divided by 40, and that is why I get 1.5. Similarly, I will do this for all the vehicles. Now moving on to the next column, this is projected area of car divided by projected area of vehicle I. So projected area of car is 5.39, and the vehicle which I see here, again car, is 5.39 is equal to 1. So that is why I get 1 here. Now projected area of car for bus, if I see, so AC, projected area of car by projected area of bus is equals to, projected area of car is 5.39 divided by 24.79 is equal to 0.217. So this is AC by AI. This I will do it for all the vehicles, and that is what I've got here. Now what is PCU? This value 1 divided by 2. So this is PCU. So I will get PCU here. Okay, I got my PCU. Now the first column is my heterogeneous traffic. Now to convert this into homogeneous traffic, I have to multiply it by the corresponding PCU value. So this heterogeneous traffic, I will multiply it by PCU to get passenger car PCU per hour. Okay, so if you see, 45 into 1 will give me 45. 8 into 6.88 will give me 55. Okay, similarly you have to multiply all this. Okay, and you have to add it all up, because now you're getting the total volume in terms of passenger car unit. Here it was heterogeneous traffic, and here you couldn't say, so you can say that so many number of vehicles per hour, but it has to be classified accordingly. 45 number of cars per hour, 8 number of buses per hour, 4 number of trucks per hour. So that has to be multiplied. So that has to be in vehicles per hour. Now, if you convert all this into homogeneous traffic, you can say it under one name, which is PCU. So you simply have to add all this up and say that in 1 hour I'm going to get 206 passenger car units. Okay. Had it been heterogeneous traffic, then I would say in 1 hour I'm going to get 45 cars, 8 buses, 4 trucks, and so on. Okay, so now that it is converted to PCU, you can say the traffic volume is 206 PCU per hour. Okay. Now moving on to the next question. Ruling design speed of 50 km per hour corresponds to. As I said earlier, the IRC classification the IRC code gives minimum speed and ruling speed depending on the type of terrain. Okay. So if you see that table which is there in sir's slides, you can see that you have 50 here, ruling 50 here, 50 here, and one more 50. 50 here. Okay. So, so this national highways in mountainous terrain has, so if you check the areas that I have encircled, it will be national highways in mountainous terrain, other district roads in rolling terrain, and village roads in plain terrain. So all these will have a rolling design speed of 50 kilometers per hour. Okay. Moving on to the next question. Capacity of a road section can be affected by what? So we spoke about capacity, but we did not talk about the factors that affect the capacity of the road section. If you see sir slides, or if you go by intuition also, you can understand that capacity will be affected by the surface condition. Say if my road is very rough, then the number of vehicles, the speed of the vehicles traveling on that road will decrease. And so, since capacity depends on speed, the capacity will decrease. Number of lanes, by intuition itself, you can understand that if there are more lanes, then the capacity is more. Okay, even though the capacity is given in terms of per hour, per lane, even if it is normalized with lane, if the number of lanes is high, the accommodation of vehicles is high, so the capacity will increase. Now, and also it will depend on road alignment. Say if there is a gradient, increasing gradient, then the speed is going to be reduced. If the speed is going to be reduced, capacity will decrease. And signalization. So if there's a signal, obviously the capacity is going to decrease. Okay, because the speed is going to decrease. So all the four are the answers to this question. Now moving on to the next question. So considering rolling design speed on a national highway in mountainous terrain and the safe stopping side distance as 65 meters, the capacity of the road section in vehicles per hour per lane, ignoring vehicle length, will be what? So they've asked capacity. We know the formula for capacity. It is 1000 into V by S, where V is the speed of the vehicle and S is the spacing between the vehicles. This is given as 65. And this you have to go pick from the table. So if you see, mountainous terrain, national highways, rolling speed, it is 50. Okay, so this V is 50. 50 is 1000 into 50 by 65 is the solution to the problem. This is 769. This is the capacity of the highway in vehicles per hour per lane. Now, I did not mention one thing. Here, I told that S is spacing between the vehicles. So, vehicles will obviously have a spacing between them. One vehicle will follow the other with some spacing between them. Usually, this S is calculated as 0.2 S plus length of the vehicle. Okay, so this is how this S is usually calculated. Sorry, 0.2 V. Here V is the speed of the vehicle and L is the length of the vehicle. Okay, this is how this is calculated. Now, sometimes if this S can also be taken as stopping side distance. Okay, stopping side distance, it comes in week 2. I'll just give a brief description, a brief explanation of that. So, what is stopping side distance? I need some distance ahead of me to stop the vehicle. Okay, so if I'm following a car, I should leave some distance in between such that say if the car before me applies a sudden brake, and if I following that, if I also apply the sudden brake, I should come to a halt without hitting the car. So my car is here and the car before me is here. Now it applies a brake at instant t1. Okay, say at time t1, this car applies a brake, and I will not immediately realize it. I will take some time to realize that the car in front of me has applied a brake, and there's going to be some lag in between. So I'm going to realize that I have that the car in front of me has stopped at time t2 and not exactly at time t1. So there's some lag in between T1 minus, T2 minus T1, during which my vehicle will be traveling in that speed, in the speed with which I was traveling. So without me realizing itself, in the fraction of a second, my vehicle would have traveled some distance. And after I realize that that car in front of me has applied a brake, I will also apply the brake. But will my vehicle immediately come to a stop? No, my vehicle will not immediately come to a stop because of the braking efficiency. My vehicle will move some distance before it comes to a stop. So for my vehicle to stop without hitting the vehicle in front of me, I should have some distance, this distance, such that this distance can accommodate for the braking efficiency, like the loss in braking, the speed covered while braking. So when you're traveling, when you apply the brake, you won't immediately stop. You will stop after you move some distance ahead. So it should cover that distance, and also the distance with which the vehicle will travel during the time I realize that the vehicle in front of me has applied a brake. So this is stopping side distance in short. Okay. So whenever I travel behind one vehicle, whenever I travel behind one vehicle, I should leave this stopping at least this distance of stopping side distance, such so that I can traverse safely without hitting the car in front of me, if at all there's if at all I have to stop my vehicle suddenly, or if at all the vehicle in front of me stops suddenly. So this is the minimum spacing that is required between two vehicles. Either this S can be that value, the S that we are talking about here can be stopping side distance, or it can be calculated using this formula, which is 0.2 times V plus L. Okay, this, if you see, it is nothing but similar to what I said. The vehicle will be traveling at V speed, say for zero point 0.2 seconds. This assumption is zero point 0.2 seconds. It is the time for me to realize that the car in front of me has stopped. So that is called as reaction time. So this plus I told that the vehicle will travel some distance before when I apply even after I apply the brake. So that they have assumed it to be the length of the vehicle. Okay, so either S can be calculated using this formula, or S can be the stopping side distance, and you can use either of the two values of S to calculate the capacity, which is what we have done for this problem. Okay, now the zone of stable flow is considered up to level of service C. We saw, right? We saw the curve, and we saw that up to level of service C, it has a stable flow. Now moving on to the next problem. So classify the terrain based on following data. So I said that based on the cross section, the topography, we saw that road can be classified into plain, mountainous, hilly, and steep. Plain, steep, mountainous, and okay, sorry, plain, rolling, mountainous, and steep. Okay, it can be classified into four of these categories. And I also said that based on the curvature, we talked about hairpin bends, right? Based on the curvature also, the terrain can be classified as high curvature or low curvature. Okay, there are values which say that if the curvature is if a particular value is less than this value, then it is called low curvature. If it is greater than a particular value, then it is called a high curvature. So if you see, this curvature is given by one parameter called degree per kilometer, and this topography is given by nothing but meters per kilometer. So this is rise and fall, and this is curvature. Okay, now how will you say that? Now how will you say that? Um, so how will you calculate this? Okay, first we will understand the problem. So this is chain age. What is chain age? If I take a particular length of a road, if I take this as 0 meters, then 0.347 kilometers, then at 0.347 kilometers, I'm taking the next reading. RL is reduced level. Okay, RL is the height. Okay, height above the mean sea level, maybe. Okay, so this height, the maybe my section is like this. Okay, so this is the roadway. Okay, it has this alignment, and this is the horizontal, this is the distance. Okay, so at 0 meters I find that it has a reduced level of 321.7 meters, and at a distance of 0.347 kilometers I see that it has a height of 352 meters. So it means that it has increased. So from 321, so let me draw it again. So this is my longitudinal profile. Okay, so this is my road. Okay, so at 0 kilometers, it is 321 meters. The height of the road above a particular level is 321 meters, and at say 0.347 kilometers. So this is the chain age which I'm talking about. And at 0.347 kilometers, the height is 352 meters. Like that, you can say that now, since this 352 is greater than 321, I know that this road section has an increasing gradient. Okay. Now, if you see the next thing, next chainage 0.993, the reduced level is 363. So again, it has increased. So in the same way, I can find out, so this I will call it as rise. Now if it is, say if the reduced level is decreasing after this, say if it is say 300 meters, I will call this as fall. And since the chainage is increasing in this way, this is called as rise and this is called as fall. Maybe if you're taking, if you're making measurements in this direction, taking this as 0 kilometers, this as 0.34 kilometers. If you are going in this direction, then this will be rise and this will be fall. Okay. Either way, the final increase, the change in gradient. Okay. So what this kilometers per hour, this rise and fall talks about, this topography is given by rise or fall per kilometer. Okay. Now, how do I find out this rise or fall? The total rise or fall I should find out. It is just the algebraic difference and sum. So how much does, so this has a rise of some meters. After that, this has a rise of some meters. So this is rise 1, this is rise 2, and again after that, this is a fall. So this is a fall of some meters. So 363 minus 300, say 63 meters. So like that, you will group R1 rises and falls. So you will group rises and falls. Now you will add up all the rises, you will add up all the falls. This will be positive because rise is always positive, right? So rise means it is increasing. So this difference you have to find out, 352 minus 321. So this is positive, rise is always positive. Now fall, it will be 300 minus 363, so it will be negative. So the total change in the gradient will be rise plus fall, the algebraic sum. So add all this up, add all this up. So this is positive, this is negative. If you take the algebraic sum, you will get the total increase or decrease in gradient in meters. Okay, this has to be divided by the kilometers. By the kilometers, by this longitudinal profile. Okay, how much distance has this covered? So if you see, it starts from 0 kilometers and it goes to 5 kilometers. So the total gradient change for 5 kilometers has to be found out. And this is nothing but meters per kilometer. This is what we find out by meters per kilometer. I will show you how this problem was calculated, but first I will just explain. Then you have to find out the curvature. Curvature is degrees per kilometer. You simply have to add all these degrees and divide it by kilometer, which is 5 total kilometers for which the measurement was made. Okay, based on these two values, the profile can be determined. Now, let us go to the solution of this problem. See, this is the problem. At chain age 0, my reduced level is 321. At chain age 0.347, it is 352. Now I have to find out rise or fall. How will I find this out? Just find the difference between the second value minus first value. So 352 minus 321 is 31.11. Now to find out the rise or fall between these two, find out the difference between 363 and 352. Okay, and that will be 10.992. Similarly, find out the difference between 362 and 363. Now if you see, from 363, the height has gone to 362, which means the height has reduced. That means that it is a fall. Okay, that is why its value is negative. Now you find out the difference between the consecutive terms, and you add all these up. This will give me 181 meters. Now it has to be normalized with the distance over which this measurement was made. Okay, or it has to be normalized with respect to kilometers. So this is for 5 kilometers. I have to find out for 1 kilometer. So divide all this by 5, which will give me 36.28. Now curvature, it is very simple. Just add all the degrees and divide it by the kilometers over which this measurement was made. So it is 5. Okay. Now if you see, for 36.288 meter per kilometer, so 36 over over 30 means it is hilly. Okay. And for a curvature of 78.4, so curvature is between 0 to 200. So this terrain will be hilly and low curvature. Okay. Now moving on to the next problem. So the possible options which can be considered to construct a road facility under scarcity of funds. So we saw that the availability of funds will also uh, define the geometric design of is also one of the factors which define the which influence the geometric design, right? So what do we do when there's a lack of funds? I said that either we can borrow money or we can do a stage construction, which they have called it as phased development, or you can go for public private partnership. What is the fourth option that they've given here? Reducing the specification of the facility. There's no way that you can reduce the specification of the facility because you're providing the facility in order to make it better. Just because you do not have the necessary funds, it doesn't mean that you should reduce the facility specification of the facility. You can follow one of the above three steps. Okay, so the answer to this is the first 3 points. Now, the safety of the road users on a road can be ensured through what? So, there was another external factor called safety. Okay, Now, if you see what factors, so what can be done to improve the safety of the road users? Either you can do a channelization. What is a channelization? Say you have um, a Y intersection like this. Y intersection is you have a road like this, you have a road like this, and you have a road like this. It is in the shape of Y. Okay. Instead of leaving it blank like this, where it can have many conflict points at this intersection, you can provide a channel. You can provide, sorry, you can provide a channel like this. So this is the road. You can provide a triangular channel like this to guide the traffic to say that you have to go like this or you have to go here and then come here. Then you can reduce the number of conflict points. Conflict points is where they meet head on and there'll be a collision. Okay. So you can so these small triangles or even in a roundabout, rotary intersection and all, this roundabout, this is also called a channel. Okay, so either you can give channelization for safety of the road users, or you can improve the alignment, or you can install road signs, or you can give a signalization. So road signs is just guiding the traffic, saying that this is ahead of you, be careful, or stop, or go slow. So road signs will guide you, whereas signalization controls you. So when you see a signal, you do not have an option. You just have to follow the signal. So by either of the two ways, you can ensure the safety of the road users. Okay. Um, Ajay Brahman, please tell me what I should explain once more. I will just get back to you after we finish this. Just two more questions. Okay. And the right of way, what is right of way? If you see sir slides, it is, you can see that it is the, so width of carriageway is, uh, sorry. So carriageway is the width of the roadway. Shoulders is the space adjoining the roadway. And there is a road margin which is also occupied along with the acquisition of this road land for future expansion. So all this together will make up for what is called as right of way. Okay. And last question is, so the solution to this problem is carriageway plus shoulders plus road margins. The minimum land width required for a road passing through steep terrain. This can be seen in slur slides. It is 9 meters. So I'll also show you the table corresponding to it. So the minimum width is 9 meters. Okay. Now that is all. Please tell me what should be explained once more, or if you have any queries, I can clarify it now. Is Ajay Brahman there? Does anyone have any queries? I see someone has lifted his hand. Please ask your question.
Good evening, ma'am.
Hello, yeah.
Good evening, ma'am.
Good evening.
मैम पेज 1 से लेकर 9 तक एक बार दिखा सकते हैं?
Actually, I'm not familiar with Hindi. Maybe someone can translate it for me, or you can try to put it in English. I'll just whatever you know, I'll try to answer. Or maybe someone can translate what he says for me. That will also be nice. Or Anvarul, you can mail me if you have any query. Hmm. Hello. I'm sorry I got knocked out. Please ask your queries now. Um, Anvarul, you can ask me now. Or Sridevi also had your hand raised. Please ask your queries now. Or if no one has any questions, then we can wind up this meeting. If you have any more questions, you can just ask in the discussion forum, or you can um, ask in the next live session, which will be on next Monday. So, shall we wind this session up? Sridevi, you have any doubts? If you feel shy, you can just type your questions or type your responses. Yes, Sridevi, you can ask. Sridevi, please ask your question. Hello? Sridevi? Okay, if no one has. Okay, Sridevi, you want to ask something? Okay, so if no one has any queries, then we can end this session. We will meet next Monday. If you have any queries, please ask in the discussion forum, or you can save it up for next Monday. Okay, thank you. You can leave the meeting.